Hello my dear students, I have already discussed section A 1 to 35 questions in my previous video lecture powered by platform. Now I will be dealing here the section B 1 to 15 questions of NEET 2021. So let us see what is the questions of the section B. First questions of the section B. Question number 36 is step down transformer to an AC main supply of 220 volt. 220 volt is made to operate 11 volt 44 watt lamp, ignoring the power losses in the transformer. So this is ideal transformer. This problem is also taken from the alternating current. And in the case of transformer, if the no power is lost, so power input, we can write power input is equal to power output, and power output given in the problem, it is 44 watt, simple 44 watt. And power transmission from one station to another station always in the form of voltage into current, so output voltage, it is 220 volt, and it is 44. So transmission current, it is 44 by 220. We can write this equation. It is 2 by 10, and finally is 0.2 ampere. So the current in the primary circuit, that is the transmission current. You know, transformer have two coils. One coil is primary coil, other coil is secondary coil. In the secondary coil, a lamp of 44 watt is connected. So output power is 44 watt and input power is also 44 watt, because there is no power is lost given in this problem. So the transmission current, that is the current through the primary coil, is equal to 0.2 ampere, and the right option here is 1. Okay, let us see the next problem. Problem number 37. A ball of mass 1.5 kg is dropped from height 10 meters, strikes the ground and rebounds the same height. The magnitude of the impulse imparted. You know, impulse, actually it means change in momentum. So if one ball is dropped from a height, if it strikes the ground with velocity v and rebound with the same velocity, then it will ascend the equal height from the height where it is dropped. Okay, so change of momentum equal to final momentum, it is mv minus mv. If I take upward direction is positive, and downward direction is negative, then the change of momentum equal to 2 mv. So this is actually impulse imparted by the ground to the ball. Okay, and the mass of the ball given in this problem, it is 0.15 kg, and the height given in the problem. So velocity, you know, root over 2gh, it is 2 into 0.15, and it is 2 into 10 into 10. I think it is 0.3 into 10 into root 2, and this is 3 into 1.4 4.2 kg meter per second. So this is the impulse imparted by the ground to the ball, 4.2 kg meter per second. Okay, so this is also very simple question and basic questions taken. You just had to find out the change in momentum, and change in momentum is known as actually impulse. Moving on to the next problem of this video session. This is the question number 38 of the NEET 2021 questions. A particle moving in a circle of radius r with an uniform speed takes time t to complete one revolution. Okay, so the speed of the particle, it is twice pi r by t. This is the speed of the particle. We can say it is speed of particle. So first stage of this problem, it is from circular motion. If this particle were projected with the same speed and it is connected to the projectile motion, if the speed is projected with the same speed at the angle theta, it is the angle theta in with the horizontal. Angle theta with horizontal, the maximum height attained by it is 4r. You know, maximum height attained, h is equal to u square sine square theta by 2g. Let us say it is u. Okay, so this is the maximum height attained by a projectile projected at an angle theta with the horizontal. And from the questions given, the maximum height is equal to 4r, that is the 4 times the radius of the circle. And u, it is twice pi r by t whole square sine square theta by 2g, and finally sine square theta equal to equal to 2g into t square, 2g into t square, 2g into t square, 2g into t square already starts matching with the option 4, 2g t square by pi square r. So theta equal to sine inverse, we can say 2g t square by pi square r to the power half. So it is also very simple questions. You can find the answer, you can find the option here by just in the middle, that is during the propagation of the calculation. You need not to go up to the last line. Just you can find here we already found 2g t square, and in all the option here, you know, option 4 2g t square. So definitely the 4 is the right option here. So you, in this way, you can save your time in the examination hall. Okay, so to save the time is an art. Okay, you have to adopt this art to how it is, how always you have to think or practice, and you have to think over how the time you can save the time in the examination hall, and to get the quick answer or quick option of this this type of problem. Okay, next questions. A particle of mass m projected with a velocity v. It is several times discussed, you know, the particle is projected up with a certain velocity, comparing with the escape velocity. I can say initially, if I started particularly for the students who want to appear for the NEET 2020 NEET 22 examinations. So I must say, you just use this formula all time. The change in potential energy, it is actually change in potential energy. Change in potential energy equal to 1 by h plus 1 by r. And because of the projection velocity equal to projection kinetic energy equal to half mv square, and this kinetic energy converts into potential energy, that is change in potential energy, better to say, when it is projected up from the surface of the earth. Okay, so 1 by h plus 1 by r, we can say 2g by v square, and finally 1 by h equal to 2g by v square minus 1 by r. And you know, it is 2gr minus v square by v square r, and height attained by the particle, height attained by this particle will be r v square by 2gr minus v square. So this is the height attained by the particle above the surface, but don't put the value here. Okay, technically some advanced formula we can find here. You know, 2gr, root over 2gr is the escape velocity. Root over 2gr is the escape velocity. So it is escape velocity minus v square into v square minus v square into v square. Finally, we can write it is equal to ve by v whole square minus 1. So h equal to, let us say r, it is n square minus 1. So this is the height above the earth surface attained by the particle where it is projected from the surface of earth, having the velocity comparable to the escape velocity. Okay, so this is the advanced formula you have to use to solve this type of problem. You don't start from here, that is change in potential energy. Don't start from here in the examination hall, particularly in the examination hall, starting from change in potential energy and kinetic energy converts into potential energy, and by this, by simple calculation, the height becomes finally r equal to n square minus 1. We have to use this formula for this type of problem. Particularly in any competitive exam, not only NEET exam, you can use this formula for any competitive exam. Okay, but the question asked in the NEET 2021, this is why I am repeating the question NEET 20 or NEET 21, but this is not this is not for only for NEET examination. You can apply for any type of examination. So height attained directly, use the formula r n square minus 1. In this problem, V equal to given kVe. So VE by V, it is actually 1 by K. I have taken this, it is N in our advanced formula. Okay, so H equal to, we can say R 1 by k square minus 1. Finally, it is r k square 1 minus k square. And the correct option here is 3. Let us move to the next problem of this video session. Question number 40. A car starts from rest and accelerates at 5 meters per second square. At 4 seconds, a ball is dropped out of the window by a person sitting in the car. What is the velocity and acceleration of the ball at 6 seconds? So here velocity of car when ball is thrown out. You know, it is thrown out after 4 seconds and it is starting from rest. It is at and acceleration of the car is 5 and time it is 4, that is 20 meters per second. Definitely from the conception we can say the velocity of ball, better to say horizontal velocity, it is also Vx, that is 20 meters per second. If any ball is thrown out of the moving system, then the ball will come out with the velocity of the system. Since the car has the velocity 20 meters per second horizontally when ball is thrown out, so the horizontal velocity of the ball is also 20 meters per second. It is the conception. Any body comes out of the system, so it will get the velocity of the system. Okay, and after 6 seconds, basically after 6 seconds, after thrown out, when ball is thrown out after 4 seconds, but we have to calculate the velocity of the ball after 6 seconds. But due to the gravity, due to the gravitational acceleration, the vertical velocity of ball Vy equal to 0, that is initially there is no vertical velocity and it is into gt, and the value of g is given in this problem is value of it is given 10, and you have to take the time 2 seconds because after 4 second time gap between 6 seconds to 4 seconds, it is 2 seconds. So ball falling vertically down for the time period 2 seconds, and it is also 20 meters per second. Finally, since the velocity is a vector quantity, so you should keep in mind horizontal velocity is 20 meters per second, vertical velocity is 20 meters per second. So the velocity of ball it is root over Vx square plus Vy square, and finally it is 20 root 2 meter per second. Okay, 20 meter per second, 20 meter per second, 20 meter per second, 20 root 2 meter per second. So 1, 2 are not the correct option here. 3 or 4. Acceleration here, there is no acceleration given by the system to the ball. Since it is freely falling body, so ball fall, the acceleration of ball of free fall, actually free fall, obviously it is g matlab 10 meter per second square. Since the ball comes out of the system, so it will descend at the acceleration g, that is the gravitational acceleration. So right option here is 4. So question is simple. You have to you just properly interpret these questions, and accordingly you have to solve. Okay, next problem. Again, the question is taken from ray optics in the section B. Another one, two questions of ray optics taken in the section A, and the ray optics question of ray optics. One question is taken in the given in the section B. That is question number 41. Here is converging lens placed at a distance 40 centimeter from a plane mirror. Okay, a point object is placed from 60 centimeter. A point object is placed from 60 centimeter. A point object is placed from 60 centimeter. It is the distance u equal to 2f, and f given here is 30 centimeter. Focal length of the converging lens is 30 centimeter. Okay. You know, from the simple conception, if the object is placed at a distance twice f, then so image of this object will form at 2f distance. So converging ray the converging rays are supposed to converge at a point from this lens. It is V at 60 centimeter. Okay, if the object distance is 60 centimeter, so the image distance is 60 centimeter. This is the nature of the, in the absence of this mirror, the nature of this image will be, the nature of this will be real. If we remove this plane mirror, if we remove the plane mirror, so the nature of this image will be real. But if we put a plane mirror, so what happened? The two converging rays cannot meet at this point. So this point becomes a virtual object. The point of convergence of two converging rays behaves as a virtual object for mirror. So mirror also can form real image. if the object is virtual. And this distance, it is 20 centimeter. So finally, after reflection, a real image is formed. A real image formed by mirror. Let us check the option given. 20 centimeter from the lens, it would be a real image. No, this is not the correct option. 30 centimeter from the lens, it would be real image. From the lens, it is actually, it would be 20 centimeter from lens, and it would be real image. 30 centimeter from plane mirror would be virtual image. This is not the right option. 20 centimeter from plane mirror, it would be virtual image. No. 20 centimeter from plane mirror, it is true, but the final image is not virtual. Final image is real. So 4 is also not the correct option. I think 1 is the correct option here. 20 centimeter from lens, and it would be real image, because if it is 20 centimeter, so the image distance from the mirror is also 20 centimeter, and since the distance between converging mirror and plane mirror is 40 centimeters, so obviously the final image is real, and from lens it is 20 centimeter, and from mirror is also it is 20 centimeter, but no such option is given. Okay, so 1 is the right option here. Next problem. 27 drops of same size are charged at 220 volt each. They are combined to form a bigger drop. So many small drops combined to form a big drop. You know, 4 by 3 pi r cube equal to n into 4 by 3 pi r cube. So therefore radius, it is n to the power 1/3 into r. Okay, and capacitance, sorry, we have to calculate the potential of the bigger drop. So potential of bigger drop, since let us say the number of drops is n, so the total charge is nq, and capacitance is c. C is the new capacitance, let us say. So it is nq, and C is equal to 4 pi epsilon 0 r. Finally, it is 1 by 4 pi epsilon 0 r. We can say nq, n to the power 1/3 into C. C is the capacitance of the small drop, and it is 1 by 4 pi epsilon 0 q by r is the potential of the small drop, and it is n to the power 2/3 multiplied by n to the power 2/3, and potential of the small drop, let us say Vs into n to the power 2/3. So this is the potential of the big drop. Okay, after combination, and let us calculate the value. 220, and number of drops 27 drops, 27 to the power 2/3, and it is 220 into 9, and 1980 volt, and the correct option here is 4. So this is also problem taken from the condenser in section B. Next problem. In the product, it is the magnetic force, you know, Q V cross B. In the problem, value of force given 4I cap minus 20 J cap plus 12 K cap, and the charge, it is 1 coulomb, it is 1, and V cross B can be written I cap, J cap, K cap. Okay, and V, it is 2, 4, 6, coefficient of IJK 2, 4, 6, and similarly coefficient of magnetic field B, and it is given in the problem B naught, okay, Z component of the magnetic field. So simply I cap 4 into 4b naught minus 6b plus j cap 6b minus 2b naught. And in this way, k cap two into b minus 2b minus 4b, simply it is I cap 4b naught minus 6b plus j cap 6b minus 2b naught minus 2b k cap. Just by comparing, you know, if we compare, first of all, we have to compare minus 2b. If we compare minus 2b k cap, here the 12 k cap, so minus 2b is equal to 12 and the value of b is equal to minus 6 Tesla. So just by finding out the value of b, 6, that is minus 6, here only one option given, minus 6, minus 8, this is not right, plus 8, it is also not right, plus 6, it is also not right, because the value of b is minus 6. So if we put minus 6 here, the magnetic field will be minus 6 I cap minus 6 j cap, and it is not necessary to check the value of b naught, because already just by comparing the k component coefficient of the k cap, we already calculated the value of b is equal to minus 6. So the right option here is 2. Next problem. This is the problem based on the gate, logic gate. Here input A, B, C. From Boolean algebra, it is AND gate, A and B, and it is also AND gate, but bubble given, this is bar, that is NAND gate. It is actually NAND gate. The output of the NAND gate is equal to B, C, B and C bar, and finally the Boolean algebra of this will be A and B or A and B bar. Okay, this is the Boolean algebra of the gate. Let us check. Here initially the value of A equal to 0, the value of B is also, it is 0. Here the result is 0. Okay, the value of B equal to 0, but the value of C is equal to, it is on. In the off condition, I have taken 0. On the on condition, that is the 5 volt, it is 1. So AND gate B, A and C, 1 or 0 or 1, that is 0 bar, and the bar of B and C, it is actually bar of 0, that is 1. And since it is OR gate, you know, in the case of OR gate, C or D, okay, If it is 0, it is 1, then the result will be 1, either or 0 or 1. So the option, let us check option. It is 5 volt, 5 volt, and it is, when it is 1, it is 0, it is 1, it is 0, it is 1. So again it is 0 and again it is 1. So you can get the 1. So in this way, if we check all the 0, 1, 0, 1, finally we get the option is, finally the right option is 3. So output is all time will be 1. Output is all time will be 1. Okay. Next problem. A uniform rod of length 200 centimeter and mass is 500 gram, balanced on a wedge placed on 40 centimeter mark. A mass of 2 kg is suspended. Mass of 2 kg is suspended from rod 160 centimeter. So in figure, find the value of mass m. So in equilibrium, this is the rod. In equilibrium, okay, from it is given 2 kg and it is given mass m, from one end is 160 centimeter and it is balanced at 40 centimeter. Okay, and the weight of the body 500 gram will act from one end, it is 500 gram. So that will act from the one end, it is 100 centimeter, that is the, it is the center of mass. So in equilibrium, we can say moment of forces about this fulcrum clockwise and moment of forces about the fulcrum clockwise and anti-clockwise. This, the moment of forces on the both sides are equal and opposite in sense. Okay. Therefore, we can write 2 kg into 20 centimeter. In the left hand side, it is 20 centimeter, it is 2 kg. Deliberately I have given chosen in the one physical quantity in kg and another physical quantity in CGS system, that is centimeter. This is not the problem in this problem, and a similar quantity you can get in the right hand side also. And it is half kg. It is half kg, 500 gram means half kg, and the distance from the fulcrum, this distance is 100 centimeter and this distance is 40 centimeter. So this distance is 60 centimeter. So this is 60 plus distance from the mass from one end is 160 centimeter and from this end to distance of the wedge is 40 centimeter. So this distance is 120 centimeter. So m into 120 centimeter. Okay. So it is 40 and 30 plus m 120 and finally 120 m equal to 10, and the mass required to keep this rod in equilibrium condition, it is 1/12 kg. both the side having the kg centimeter, it is also kg centimeter. So not necessary to change the centimeter into meter, because the similar quantity having in the both sides of the equation. So the mass required for this problem is equal to, it is 1. Question number 46. Next problem, let us see. A uniform conducting wire of length 12A and resistance R is wound up as a current carrying coil in the shape equilateral triangle of side A and a square of side A. So in the case of equilibrium, in the case of equilateral triangle, the number of turns is equal to 12A by 3A, and it is actually 4. So magnetic moment is equal to Nia. Number of turns of the problem is 4, and the current in this problem given is capital I as per the option given, and the area of the equilateral triangle is equal to root 3 by 4 a square, and finally it is root 3 I into a square. Okay, root 3 I into a square, root 3 I into a square. So I think 2, 3, 4 are not the correct option. Only by checking one only, if we find the magnetic moment of the current carrying coil, that is the equilateral triangle, it has the 4 turns. The total length of the wire is 12A, but the periphery of the equilateral triangle is 3A, so number of turns is 4. And if we check the just one, in the case of equilateral triangle, that is magnetic moment is equal to root 3 I into a square, so right option here is 1. Okay. So not necessary to check the other option, other magnetic moment in the shape of the square. Let us move the next problem. Two conducting circular loop of radius R1 are placed in the same plane. One is very small, radius is R2. One is very small, radius is R2. And other wire radius is R1. Okay, because given in the problem, given R1 greater than R2, so in the central region of the coil R1, we will get a uniform magnetic field. So as per the convention, if we find out the mutual inductance between these two coils concentrically placed, so as per the convention, we have to take the current passing through the outer circle. If we get the current through the outer circle, so we get the uniform field at the central region. Since this since this circular wire is radius is greater than the radius of the small circular coil. Okay. But if we take the current through the R2, current through the circle of radius R2, the mutual inductance will remain same. If we take the current through the outer circle, what we get the mutual inductance? If we imagine the current passing through the inner circle I, and the mutual inductance of this combination, it will also remain same, because mutual inductance of this combination remain constants, whatever may be the, if we take current outer circle or inner circle, whatever may be the mutual inductance does not change, because their orientation, their separation, everything is fixed here. Okay, they are both the circular coil placed concentrically. But if we take the current through the inner circle, what happened? The magnetic field outside this coil, we have to consider the magnetic field outside this coil and inside this coil, and magnetic field also will not remain uniform. But if we take the current through the outer circle, since this circle is very small, so in this central region the magnetic field due to this circle will near about uniform magnetic field we can get and passing through this circle, passing through this through the plane of this circle. Okay, so the mutual for calculation the mutual inductance flux through this, it is actually B1 into A2, that is the area of the small circle, because in this region we can get the uniform magnetic field, and this uniform magnetic field is equal to mu 0 by 4 pi 2 pi I by R1, and it is actually pi R2 square. Finally, mu 0 by 4 pi 2 pi R2 square by R1 into I, and this can be written as mutual inductance into I. So phi is equal to mutual inductance into current through the coil. So mutual inductance, it becomes mu naught by 2 R2 square by R1, and this mutual inductance is directly proportional to R2 square by R1. So as per the convention, since the radius of the outer circle is greater than the radius of the small circular coil, so as per the convention we have to take the current through the outer circle, and the mutual inductance is directly proportional to the R2 square by R1. Okay, next problem. From a circular ring of mass m, it is perpendicular to the plane through center. Okay, the mass of this part is m by 4. So the moment of inertia of circle, you know, it is mr square, and the moment of inertia of the removed part, since it is 1/4 of the total, it is 90 degrees, 1/4 of the total, the mass of this part is m by 4. So moment of inertia, it is 1 by 4 mr square. So moment of inertia of rest part, moment of inertia of the rest part, let us say it is I, it is IC, and moment of inertia of the removed part, therefore it is mr square, 1 by 4 mr square, and finally it is 3 by 4 mr square k mr square, and the value of k is 3 by 4. Simple questions, and the only one questions taken from rotational mechanics in NEET 2021 in the section B. 3 resistors having resistance R1, R2, R3 are connected as shown in the given circuit. The ratio of I3 and I1. We have to find out here I3 by I1. I3 is the current, I1 is the current through this, and the resistance of this is R1. Resistance of the upper branch is R2, current through this is I2, and resistance R3, current through this is I3. Okay, we have to find out the ratio of I3 and I1. You know, current divides into parts. Here the total current entering into the circuit is I1 and the total current entering into the circuit is I1, and current divided into parts in inverse ratio of resistances. We have to find out the current through R3. So you put R2 since it is inversely proportional. If we want to take the current through R3, you have to write the resistance parallelly connected with this is R2. So R2 by total resistance. Okay. So this is current division rule. Similarly, if we want to get the current I2, total current entering into this is I1, you have to write here R3 by R2 plus R3. So very basic questions, and a question is asked on the current division rule of the chapter current electricity. So simple I3 by I1, it is actually R2 by R2 plus R3. Okay. Right option here is 2. Next, question number 50. A series LCR circuit. Again, the problem taken from the alternating current in the section B. Similarly, one question is also taken in the section A from alternating current of NEET 2021. And this is last questions of this video session. I hope you are understanding and getting the correct option. Next, here the angular frequency of the source at which the power transferred to the circuit is half the power at resonance angular frequency. At resonance angular frequency, frequency omega naught equal to root over of 1 by LC, and it is root over of 1 L. The value of L is given is 5 and it is 80 into 10 to the power minus 6. Finally this becomes 10 to the power 3 by 5 into 80, that is 400. Root over 400 is 20. And the value is 50 rad per second. So this is the resonance angular frequency of this AC source. And you know, half power. In the case of half power, we have to find out the band gap. Band gap or bandwidth, we can say bandwidth of this LCR circuit, it is omega 2 minus omega 1 is equal to R by L, and 40 by 5, it is 8 rad per second. So in the both side of the maximum power, that is a resonant frequency, you know, if we put a graph, you know, this is the resonance. In the case of resonant frequency, the power will be half. It is omega 1 and omega 2, and this is known as bandwidth of the LCR circuit, and bandwidth is equal to, theoretically it is R by L, so 40 by 5 is equal to 80 rad per second, and it is from the resonant frequency, both the side is equally interval. So omega 2 equal to, we can say, resonant frequency plus 4, and similarly on the other side omega 1 equal to omega naught minus 4, and it is 54 rad and it is 46 rad per second. Rad per second. Okay, so the correct option here is 3, and in this way I have discussed 1 to 15 questions, and I try my best to make you understand all this problem as simple as possible. I hope you can find the correct option here, or you can check your answers, you can check your score from this video session. Best wishes from our side and from the leading institution platform. That's all.